Just like when we had truth tables, you need to understand the basics in order to understand how to work out an Euler diagram or a syllogistic argument. So what I'm going to go over here are just our basics. Okay? When you have a statement that says all A's are B's, so for example, saying all birds can fly, okay? We're going to represent that by drawing a diagram of two sets, one within the other. Notice we're using Venn diagrams here. And since all A's are B's, the set A is contained completely inside the set B. Okay? And I label my diagrams appropriately. Notice that A is inside of B because all A's are B's. Okay? The other statement we're going to run into is no A's are B's. In the case where no A's are B's, I can represent both A and B as a set with a circle here. And notice they do not overlap, which is saying none of these are any of those. And finally, to represent some A's are B's, I draw my two sets with an overlap. And then the elements that would fall in the overlap here are some of the A's that are also in B. Use an Euler diagram to determine whether the argument is valid or invalid. And here is an example of an argument. Now, how we're going to work out these arguments is we're going to try to disprove the argument. If we're not able to disprove the argument, then we're going to say it is valid. But if we can find a case where the argument is not true, then we can say that it's invalid. Okay, so remember that. We're trying to find the case where it doesn't work. Because if it doesn't work, then it's invalid. If we can't find that case, well, then it has to be valid. Okay, so notice again we have a typical argument set up here. Okay, we've got these two statements and then our conclusion. So I'm trying to prove this conclusion is not true. Okay, all right, so the things we know are the things that are up here, what we called before our numerator, if we're going to think of this as a fraction. So the first statement says that all plumbers wear overalls. Okay, now remember the way we draw this one for all A's are B's. So all plumbers, so this is the set of plumbers, wear overalls. So all of these are in the set of people who wear overalls. All plumbers wear overalls. Okay? Now my next statement says that some electricians wear overalls, and my conclusion is some electricians are plumbers. Now remember, I'm trying to disprove this, because if I can show it's not true, then it's invalid. So when I go to draw some electricians wear overalls, okay, I could draw my circle overlapping overalls and also overlapping plumbers. But remember, I'm trying to disprove that some electricians are plumbers. So I'm going to try to draw the circle that has electricians separate from plumbers, because I want to disprove this. And sure enough, if I put a circle for my set of electricians right here, I've shown that some electricians wear overalls. And I've disproved this conclusion that says some electricians are plumbers, because electricians and plumbers do not overlap. So we can say that this is invalid. Okay? And remember, we were trying to disprove the statement. All right, here's our next problem. No candy bars are health foods. All Snickers are candy bars. Therefore, no Snickers are health foods. All right, and again, it's a syllogistic argument because we have alls and nos and sums. So I'm going to be drawing my little circles for my Venn diagrams. and I'm trying to disprove the conclusion. Okay, well, let's see what we got here in our first statement. No candy bars are health foods. Well, that one's the one where we have two separate sets. So that's a set of candy bars. And this is the set of health foods. So no candy bars are health foods. All right. The next statement says that all Snickers are candy bars. Okay. Well, there's only one place where I can draw Snickers, and that's inside of candy bars. So this is the set of all Snickers. All Snickers are candy bars. Notice here I really didn't have a choice on how I've drawn my diagram so far. So now let's look at the conclusion. Does it follow that no Snickers are health foods? Well, according to the diagram I drew, sure enough, Snickers and health foods do not overlap. So it is true that no Snickers are health foods. So this argument is valid. All right, here's my next problem. All golfers have rain gear. John has rain gear. Therefore, John is a golfer. Okay, so again, I have one of these syllogistic arguments. And my whole plan of attack here is try to disprove the conclusion. All right, and my conclusion being that John is a golfer. All right, so let me start with the first given statement. All golfers have rain gear. Okay, so all golfers, this is the set of golfers, have rain gear. So this is the set of everybody who has rain gear. Okay. The next statement says that John has rain gear. All right, so in this case, I just need to make sure that John gets placed somewhere inside of rain gear. All right, well, remember, I'm trying to disprove the conclusion, and the conclusion is that John is a golfer. Okay, so when I go to put John has rain gear, I could put John here or here, as long as it's inside this circle. I'm going to decide to put John here, John being an element, because in this case, the conclusion doesn't follow. Okay, the conclusion is John is a golfer. In this case, John is not a golfer. Since I have found a case where it's invalid, the whole argument is invalid. Remember, I don't care about the case where it's true. I want to find a case where it's false. Because if I find one, the whole argument is invalid.